let's get into it. So overall, we have the whole workshop divided into 3 sessions. We'll focus on simple averages, weighted averages. I'll start off with some very simplistic things overall, how I think about averages in the first place. And then we'll do some official questions also. We'll look at mixtures, again, the groundwork of mixtures, how I look at mixtures, how I think of mixtures, questions, how I'm able to relate real life understanding here. We'll do official questions related to those also. What we'll also look at are some questions which in the first look might not appear to be average questions. They won't have the word mean or weighted average or average in them, yet they can be answered using the concepts of weighted averages. So yeah, while these are the things we'll cover, and for the most part, the sessions will also be divided like this, but at the same time, there will be overlap also. So it's not like, oh, the second session is only about mixtures, the first session is only about these things. There will be overlap as well, but overall, these are the things we'll cover. The main focus of when I'm discussing questions will be on the non-traditional approaches. So I will not spend a lot of time on, oh, this is how you could answer a question using a formula. This is how you could get to the answer. Now, let me be clear. That doesn't mean that I'm denouncing those approaches. I'm not saying, oh, those are bad approaches, forget them. No, but I find, like I said initially also, often people are still relatively comfortable applying those approaches. The problem for me is that when you're using a formula, often it becomes something that would happen with an Excel file, for example. You plug in a formula in one cell, you have values in other cells, and then a result comes out. And then, at least it's happened with me, I know, that I won't even think about whether the result makes sense or not. As long as that formula has given that result, I'm happy with it. And I might not even notice, oh, hold on. The answer, it's talking about the population of a country and it's only in hundreds. I won't even think about things like that. How can the population be in hundreds or thousands? And population needs to be much more. So those kind of basic things also often I miss out on when I'm being formulaic with my approach. Also, like I've mentioned before also, we will keep it interactive. So yes, significant portion of our discussion will be driven through the questions you guys ask also. So don't hesitate there at all. No judgment with regards to questions. There are no silly questions. Let's be very clear about that. We're all here to learn. If you guys were good at this topic, you wouldn't have enrolled in this workshop. So since you're all here to learn, by all means, ask questions. Don't stop just because you think they're silly, or in fact, don't even think of questions as silly. Second, your question could help others also. So that's an added benefit. All right, let's get into it then. Here's the first question. It's a yes/no question without any options. It's a part of a GMAT question, but I've modified it slightly. Can the following statement be inferred from the data above? So what's the statement? The family's average annual income for this period shown was greater than 40,000 or not. That's what we have to figure out. So the goal is not to figure out the exact value, but just figure out whether it's greater than 40,000 or not. Where is 40,000? There somewhere in the middle. So fine. One way, of course, is that I look at each value. Oh, this one is 25,000. This one is maybe 26,000, 26,000, and so on. And then add them up and then divide by the total number of values, right? But yeah, that will be too cumbersome. That will take quite a lot of time. Plus so many calculations, and that too, there will be approximations also. This guy here, for example, not exactly 40,000, slightly less. Is it 39? Is it 39.5? Is it 38? How do we decide those things? So we'll revisit this question after a bit. Make sure you note your answer, yes or no. Anyway, you probably remember, but just write those answers down also. So one more question, and then we'll discuss both of them together after. Go ahead. So help me understand then. This particular question, how did you find it? Or how are you finding it? Easy, medium? What's it like?
I thought for me was easy because I just use basic school mathematics that we have learned.
What else? How did the rest of you find this question? Easy, medium, hard?
Anish, I also got the answer D. I have submitted on the poll. So yeah, same logic is the same. I've used what I had sort of learned in school on averages.
Tell me about that.
So essentially, I got to know that the total is 4,000 because 400 into 10, and for the first 6 days it's 360. So 360 into 6, which I got as 2160. And essentially then the balance is 1840, so which is for the remaining 4 days. So 1840 divided by 4 would give you 460 per day.
Got it. Cool. So what we'll do now, we'll take a detour for some time. We'll come back to both these questions, but I want to go through this process first. So why don't you try this question? 5 kids have the following number of chocolates. What's the average number of chocolates each kid has? Once you're done, tell me your answer in the chat. Yeah, everyone's got the correct answer. Indeed. So that's sorted, right? The answer is correct. Now, a very important part of averages, as for many quant questions, is not just about whether you know how to answer it. It's also about whether you can answer it within that stringent time limit. And then how do you do that? So one is that you get better at, for example, addition. You are able to quickly add 74, 76, 77, 78, 81, and you're able to quickly divide that by 5. The other is that you figure out some other way to get to the answer. Right? It's not necessarily about just doing the same steps faster. It could also be about looking at the problem in a different way. So the traditional approach, for example, adding up all the numbers and then dividing by 5. Remember, we're talking about kids and chocolates. So one way to think about this approach is that I've taken all chocolates from all the kids. Now I've got the total, and then I distribute them equally among the kids, right? Divide by 5, I give each one equal chocolates. So that's one way to visualize it, right? What the traditional approach essentially is, I take all the chocolates and then divide by 5, give them equally. Now, tell me, does this make sense that when we've been asked to figure out the average number of chocolates, essentially one way to think about it is that after all this addition, subtraction, division, eventually each kid should have an equal number of chocolates. One way to think about it. When we get to that average figure, one way to think about that is that everyone should have equal chocolates after all this processing and everything. Does that make sense? Essentially, average is nothing but distributing evenly. Anyone to whom this is unclear? Okay. So, if that's the objective, to distribute the chocolates evenly, then one way to think about the whole thing is that, okay, instead of taking all of them and then starting to distribute again, maybe I can let all the kids keep 70 chocolates each as a base. That many you keep, give me the extras. Those extras I'll distribute. Anyway, then my calculation also becomes easier. Think about it. But now I'm not thinking of it from a maths perspective, right? It's a realistic problem. I can visualize. There are 5 kids in front of me. They have different numbers of chocolates. My objective is to distribute the chocolates in such a way that by the end, everyone has equal chocolates. That's it. So I say, okay, fine. You all keep the 70, 70, 70. Give me the extras. So you give me the 4, the 6, the 7, the 7, and the 11. I add up these numbers, divide by 5. These are the extra chocolates then that I give to each one. So that's another way to think about it. Mathematically, this is much simpler than starting with 74 plus 76 plus 77 and so on. So this is 10 plus 14, 24 plus 11, 35 divided by 5. That's 7. So remember, I've taken 4 from the first kid. So the first kid has 70 left, had 70 left after giving me 4. The second kid had 70 left after giving me 6. The third had 70 left. The fourth had 70 left. The last had 70 left. And then the 35 chocolates that I collected, I will divide them equally. So each one will get 7. And that's another way of saying that the average is 77. This much clear? Okay. So now, do I even need to start with 70? Not necessarily. I can actually start with any number. I'd rather start with a number which makes sense for me, which reduces my calculations. So, for example, I could start with 74. And then the first kid doesn't give any. The second kid gets only 2. The third kid gives 3. The fourth kid gives me 3. The last kid gives me 7. Now they all have 74 each. These are the extra ones. How many extras do I have? 5, 8, 15. So then 15 by 5, 3. I give back 3 chocolates to each of the kids. They had 74 before. I give them 3 more each. They get 77 each. Again, got to the same answer. In fact, I could even think of creating the base as 77. So I'm thinking, okay, let's say these guys don't give me any chocolates. You keep your 77 chocolates. This guy, the 81 guy, has 4 extra. So then he gives me the 4 chocolates. The first person has 3 fewer chocolates than 77. The second person has 1 fewer chocolate, 1 less chocolate. Ah, nice. So those 4 extra, I'll give to the first guy, 3 to the first guy, 1 to the second guy. Right? So basically, when I start with a base of 77, then if I'm thinking mathematically, I have a +4, I have a -3 and a -1, and then +0, +0. So overall, that balances out. Basically, when I'm starting with 77, then I don't need to, by the end I get 0. So then everyone has equal chocolates already. Another way to think about this is that basically, I asked the kids, why don't you distribute among yourselves? Till the point, everyone gets equal. So now try to visualize it. Don't think of it mathematically. These 2 kids, I tell them, okay, you stay. As a starting point, why don't you, the guy with 81, let's say give two chocolates to the guy with 74. So then you have 76, 76, 77, 77, 79. We're closer. So then I'm thinking, okay, this guy still has extra. So why don't you give 1 to the first guy, he gets 77. And then the last one's at 78. The second one, that's 76. Then I'm thinking, oh, why don't you give 1 to the second guy also? And then everyone ends up with 77. That's the average. Right? We can think of average in this way also. So the starting point was that one way to visualize the whole problem is that I want to distribute the chocolates equally among the kids. We start, and when we add up all the numbers and then divide by 5, that's essentially taking all the chocolates from everyone and then giving them back equally. Think about it, it's so much work. Instead, I could just get them to distribute evenly. Overall, there were so few transactions. The guy with 81 had to just give 3 to the first guy, give 1 to the second guy, and then we're done. Everyone has 77. Compared with adding up those 5 complex numbers, much less maths. Okay, let's try this now. So we have 3 younger kids with 10 chocolates each. We have 3 older kids with 20 chocolates each. What's the average? Or another way to think about it, how can I evenly distribute these chocolates among the kids? Tell me. What's the number? So in case you are doing 3 into 10 plus 3 into 20 divided by 6, pause. That's of course one approach, right? I figure out the total 3 times 10 plus 3 times 20 divided by 6. But I don't even want to do that much. Again, notice 3 older kids have extra chocolate, have excess chocolates. So one way to think about it is that, okay, let everyone keep 10, 10, 10, and the extras I will take first. So 3 kids have 10 extra chocolates each. Overall, those 30 chocolates I collect. At this point, we're still in the middle. At this point, every kid has 10. And I have the extras. How many extras do I have? 30. So then those 30 chocolates, I divide back among the 6 kids, all 6 of them. So 30 divided among 6 kids. That means each kid gets 5 more. They already had 10 from before. They get 5 more. They end up with 15. That's one way to think about it. Or again, there are 3 older kids, 3 younger kids. I'm not even going to try to draw kids. These are kids. They have 20, 20, 20. These guys have 10, 10, 10. So now think of it this way, that, oh, if the 120 guy gives 5 chocolates to 110 guy, one older guy gives 5 chocolates to one younger guy, these both will end up with 15 each. And in fact, the same thing can be repeated by these 2 kids also. The same thing can be repeated by these 2 kids as well. So each one gives 5. Each one gives 5. And then eventually they all end up with 15, 15, 15. Now, in case this is clear, yet your first instinct when you saw this question was to get into 3 into 10, 3 into 20 divided by 6. Understand, this is what we need to, this is the stage we are at. Just knowing something is not enough. We need to apply it also. And so often there are 2 separate silos. Oh yeah, I know how that works. Yet, when it comes to solving questions, I'm going to use what I'm comfortable with already, my traditional approach. So let me ask you one question, or rather one thing to think about. Why is this GMAT test even there in the first place? Why do we have these average questions? Why do we have this quant section or DI which have these average questions? What's really going on? Do they want to test how good we are at school maths, essentially? If that's the objective, why can't they just look at our marks from school? Sure, different boards, different countries, but they can probably figure out some way to standardize things. Why do we need this other test for those things? If your instinct is to solve questions traditionally, my suggestion is that try to hold that instinct initially. Right before you jump into solving and doing maths, doing the formulae, the calculations, see if you can answer questions another way also. Yeah, Param, go ahead.
No, I just wanted to say, according to me personally, it's not a test of maths, it's a test of reasoning. That's what they are looking for. That's why GMAT exists in the first place.
Yeah, makes sense. End of the day, it would be testing things that that according to them, they feel are required in an MBA also. Right? That's why it's a part of our application process. It's something that's needed for an MBA. And then if you think of it that way, then probably, yes, it is more about reasoning and logic than it is about how well can you do things that an Excel file can do. Indeed. Sure, let's continue. All right, so let's come back to this question then. So what's going on here? In a small snack shop, the average revenue was $400 per day over a 10-day period. So they're not talking about boys and chocolates or kids and chocolates here, but still maybe we can relate. I'll talk more about this. During this period, what period? The 10-day period. If the average daily revenue was 360. Oh, for the first 6 days. Hold on. So already they're talking about 2 separate averages. One, what's this 400? What's this 360? They're both averages. So one is the average per day over the 10-day period, over the entire duration. And the other is the average for the first 6 days. And then what's the question? What was the average daily revenue for the last 4 days? So we're dealing with three separate averages here. Overall average, average of the first 6 days, average of the last 4 days. Sure, we can think in terms of averages, but I want to think more in terms of, again, kids and chocolates. How? Well, there are 10 kids and the revenues are chocolates. So the days are kids, right? Overall, it's a 10-day period. So let's just think of it as 1st January till 10th January. And each day has revenues, or each kid has chocolates. And then they've told us a bunch of things. The first 6 kids have on average these many chocolates. Overall, the group has these many chocolates. How many chocolates to the last, or what's the average of the last 4 kids? So if I think of it in that term, I'm going to now think of everything in terms of deficit and extra. Basically, first 6 days are short by $40 each. Overall, if you were to distribute all the revenue evenly, then each person would have $400. Each day would have $400. But actually, the first 6 days, on average anyway, have fallen short. So what does that mean now? The first 6 days have fallen short. That if they were to try to do an even distribution within themselves, the 6 kids, then each one would have 360 exactly. How much exactly an individual has, I don't know. How much exactly was the revenue on a day, I don't know. But if they were to distribute the revenue evenly across the 6 days, each one would end up with 360. This much I know. Now, does it mean that only one person has 360 into 6, everyone else has 0? It could be. Does it mean everyone has exactly 360? That could also be the case, or anything in the middle. But at least I know, all right, if they were to distribute evenly, they would end up with 360 each, which means the first 6 days are short by $40 each. Now, this shortage of the first 6 days needs to be compensated by the last 4 days. Compensated how? So that overall, eventually, the overall average becomes 400. Right? So first thing I understand that the last 4 days would need to have extra chocolates or extra revenue, which is evident in the answer choices also. They're all greater than 400. The last 4 days would need to have extra. How much extra? Exactly as much as the shortage is in the first 6 days. Right? They need to balance completely, evenly. So then what's the shortage in the first 6 days? $40 shortage each day. Overall, 6 such days. This much is the shortage. This shortage needs to be compensated by the last 4 days. In other words, the last 4 days will have this much extra. That much extra overall. So that means on average, they would have 6 into 40 divided by 4 extra on average. 6 into 40 by 4. 40 by 4 is 10. So 6 into 10, 60. Remember, this is the extra bit. What they have beyond 400. So overall, what's the average for the last 4 days? The base 400 plus the extra 60. The average for the last 4 days is 460. So again, I think everyone would have got the answer here also. But what I am really interested in is you guys focusing on the approach. Right? Notice no complex calculations, what 360 into 6 is, and then subtracting that figure from 4,000 and then dividing by 4. No complex calculations like that. Why I was able to do that? Mainly because I could visualize the problem. I could understand what's really going on here. I could relate it with my kids and chocolates example. Notice one more thing. Even this small calculation, 6 into 40, I didn't convert that into 240 even. It's not very complex, but even then, whatever multiplications, divisions, additions I need to do, I leave those till the last step. Because many times I find that there will be cancellations and things like that. And overall, I don't need to get into complex calculations. Leave it as 6 times 40. Then when I'm later dividing by 4, wonderful, 40 by 4 is 10. So I'm done. 6 into 10 would be 60. I'll give you a moment to process. But now, if it's clear, tell me what's 29 times 31. If it's not clear, then you can just say not clear. So how can we do this? 29 times 31. One way is to think about it. It's 30 plus 1 times 30 minus 1. 29 is 30 minus 1. 31 is 30 plus 1. So then overall, we get 30 square minus 1 square. 30 square is 900 minus 1, 899. Chalo, all right. Now, yeah, back to this question. Here also, what's the question? Was the average greater than 40,000? I notice 40,000 is here in the middle. So for example, these people are already quite close to 40,000. Slightly less, but quite close. Okay. Now, these guys, then I'm thinking, oh, so this person, for example, is at something above 55. So he has more than 15,000 extra compared with the average. So he can, let's say, give, for example, 10,000 to this guy, and he would reach 40,000. He still has 5,000 left. He can give 5,000 to this guy. He will come somewhere over here. This person is at about something more than 60,000. So he has more than 20,000 buffer. So he can get this 25,000 wala guy. He can give 15,000 to this person, get him to 40. He would still have some buffer. Same way, the last guy can also reach 40,000. They can all reach 40,000. And even then, and there would be a lot of buffer left, which can then be used for these people to push them over 40. Here, I'm not trying to calculate the exact average. My objective is to check whether the average is greater than 40,000 or not. So that's what I'm keeping in mind. That, okay, if the richer people give money to the poorer people, or basically they talk about years, but still I'm thinking in terms of if they can give revenue to the lower values and push them beyond 40, then I'm happy. And I noticed that, yeah, all those higher values do have enough buffer to get these people to beyond 40. All of them, all these lower years can get beyond 40, and even then buffer will be left. So that's why the answer becomes yes. I don't need to necessarily calculate the overall thing. I anticipate, and tell me if this is correct, that when you saw this question, the graph, maybe my guess is that you did apply this kind of visualization that it's just about the difference, and they can compensate, versus when you did the other question about revenue in 10 days, then probably it was more mathematical for you. Is that true for you? That maybe you were able to visualize this and didn't need to calculate the exact thing, and you did calculate the exact thing in the other one. Huh? Yeah, Namita, that happened with you also?
Yeah.
So ab dekho, here, because it's already visual, maybe it was easy for you to then just take that one extra step to visualize the whole thing. Right there, it became more of a mathematical problem. So then one takeaway becomes that try to visualize problems before you get into solving them. All right, let's continue. Dun, dun. So overall, these are the kind of non-traditional approaches that I'll be focusing on. Reasoning-based, logic-based. Often we will use answer choices. Many times we'll work backwards from answer choices. We'll eliminate answers that anyway can't be correct. We'll do these kind of things. Often when I get into things like this, a question that comes to students' minds is, but what if the options on the exam are actually different? Okay, fine, here the options were this way, and so you were able to apply these approaches. But what if the options were different? And that's a good question to ask. It is a good question to ask, but there's a place for it. You can try to figure that out yourself also after you're done answering the question, using all the resources that are there at our disposal. So step one is to answer the exact question as presented. Remember, the questions you'll see even in an official guide or on GMAT Club, the official questions are all past GMAT questions. So they've appeared exactly that way on actual exams. So step one is to answer that exact question. And then afterwards, you can think about, okay, what if the options were different? What if this language were different? What if this value were different? Then how would I handle it? By all means, do that, but not as step one. Step one is to develop the skill of using all the resources that are there, and answer choices are a resource also. So we should use them. All right. Chalo. Here's another one. I'll give you a couple of minutes. All right, let's take a look. The average of 3 different positive integers is 100. And the largest of these 3 integers is 120. Okay, so because we're just starting, I could still link this with chocolates and kids. Okay, there are 3 kids. If we were to distribute the chocolates evenly, each kid would have 100 each. The richest kid has 120 chocolates. Now, what is the least possible value of the smallest of these 3 integers? First, let's be clear about the language here. Least possible value. So which already means that maybe there are multiple different possible values. Out of the various possible values, I have to figure out the least one. How can there be multiple different possible values? Let's try to think about that. Okay, so we know that I'm calling it the richest kid. We know that the richest kid has 120 chocolates, or the largest integer is 120. And I know that the overall average is 100. I don't know about the other two values or the other 2 kids. So how does that matter? Well, for the overall average of 120, I can have something like, let's say, one value is 120, one value is, let's say, 100, which is the exact average. And then whatever extra is here, I will make that a shortage for the last one. So then overall, I get a value of 100, average of 100. So I was able to figure out one value at least, one set of values. But then again, they're asking for least possible value. How can there be different values? Well, already I can think of one more example. For example, the first integer has 20 buffer. So let's say that's distributed 10-10 within the other 2. Already I'm starting to understand. Oh, it's not like the other 2 values have to be fixed. So now my goal, let's say, is to minimize this last value. In other words, the last value should be as small from 100 as possible, as far away from 100 as possible. Or the shortage should be maximized. In other words, I want to give this guy extra chocolates also. The first guy already has extra chocolates, or one value is already more than 100. Second one also I'll give extra so that they both contribute to the third. So this one has to remain fixed. How much extra can I give to the second person or the second day or the second value? Well, the maximum is 120, so I can't go till 120. Okay, we are talking about positive integers, so I can go till 119. So now here there's a buffer of 20, here there's a buffer of 19. So overall, for the last one, there can be a shortage of 39. Shortage of 39 on 100. So 100 minus 39, 100 minus 40 is 60, plus 1, 61. That becomes the answer. Okay. Chalo, let's try another one. Notice this time, it's not an official style question, which all of the following. So any combination of these could be correct. Go ahead. Let's start with Harshin. Harshin, your answer is A and B. So before we get into the answer, can you explain what you've understood from the question?
I would now like to say it should just be B. But anyway, there's one set which has 9 different numbers, and then there's another set which has 8 different, but that all of them are the part of the first set. So in any case, because the first set has one extra number.
One minute. So processing we'll do later, but I still want to make sure you've understood the question. So can you maybe take an example to explain what's going on in set S, what's going on in set T?
So set S is 0, 1, 2, 3, 4, 5, 6, 7, 8. Set T is 1, 2, 3, 4, 5, 6, 7, 8, or 0 to 7, whatever. And then what can be the inference about the means of these two sets?
What can be the inference? So let's focus on
whatever
that. Which all of the following statements cannot be true? What does that mean?
Cannot be true.
What is that?
So both these sets will have mean A and mean B. Sorry, mean S and mean T.
Hold on. Mean is there in the statements below. My question is, what does that mean? Which all of the following cannot be true? Just tell me, in general, what does this language mean?
What cannot be true? So what is false?
What
essentially?
What is cannot be true? There's no way something can be true. That's what we're looking for.
Yes, out of these statements, what in any circumstance, any scenario cannot be true.
So if I find even one circumstance in which a statement can be true, then would I select that or would I reject it?
No, you will, if there's even one possibility that it can be true, then that means that you will not select that statement.
Okay. So Harshin, let me first assimilate all this. So two things. One is, anyway, set T is kind of a subset of set S, right? Set T has 9 different numbers. Set S, again, obviously we'll have 8 different because they're all from set S only. But set T has 1 less number. So like an example, Harshin took 0 through 8, and then let's say 1 through 8 or something like that. In my mind, I thought of numbers from 1 till 9. 1 till 9 in set S, and then any one of these numbers is removed in set T. That's one thing. The second thing, which all of the following statements cannot be true. Cannot be true. So what exactly I need to do when it comes to the statements, I understand through this phrase here. How exactly will I deal with the statements? If I find even one situation in which a statement can be true, then that statement will get rejected. Then that will not be a part of my answer. First of all, tell me, is everyone clear about this aspect? That how will I reject an answer if I find even one, essentially, exception? Even one situation in which the statement can be true. Two questions. One, is it clear now? Second question, was this your understanding initially also? Why I'm asking that? Because I don't think anyone gave me that answer. The answer here is none of these. I got some combination of A, B, and C, but actually, which of the statements cannot be true? They can all be true in some situation. So either it was an issue in terms of understanding what the question is asking for, or maybe it's an issue of understanding what the sets really are, or it's an issue of, oh, you couldn't think of a case. Let's see. We'll figure that out. So let's deal with this now. Let's look at the first statement. So what am I going to do now? How am I going to deal with this statement? I'm going to check, is it possible? Is it possible that the mean of set S is equal to the mean of T? So let me continue with this example. So let's say this is set S. Set T will have 8 numbers. All those 8 numbers will be out of these 9 only. So I can ignore any one. I can leave out any one. Now, remember, the question is, which of the following cannot be true? So my goal is to check, is it even possible that the averages are equal? In one case, the average will be sum of, let's call it S divided by 9. In the other case, the average will be sum of, let's call it T divided by 8. So how can I make the averages equal? I'm not going to think about it mathematically. I'm going to think in terms of chocolates again. There are 9 kids with these many chocolates. First kid has 1, second kid has 2, and so on. If these kids were to distribute their chocolates evenly, they would have 5 each. So then I'm thinking, okay, what if I leave the 5 wala guy out and put everyone else here? Then yes, these 8 kids will be able to distribute evenly among themselves and still end up with 5. So is it possible that the mean of set S is equal to the average of set T? Yes, it is. It is possible. That's all I care about, right? Which one cannot be true? So as long as this one can be true, at least in some situation, it's rejected. Now, doesn't mean the averages have to be always equal. But as long as I can figure out even one situation in which the averages can be equal, the statement gets rejected. I'll give you a moment to process that. All right, so that's one. So I'm going to look at the second one now. Again, remember, the question I'm asking is it possible? The question is not, will it always be the case? But is it even possible that the average of the bigger set is smaller than the average of the smaller set? So what do you think? Tell me now. Is that possible? Let's keep S as the same number, same set, 1 till 9. Tell me this. What number should we remove from S such that the average becomes less? Of S becomes less than average of T. What number should we remove? What kind of number? Basically a small number. Indeed, Kanav, something like 1. Right? I remove a small number. Then I only have those bigger numbers left. So overall, then the average of S will be less than the average of T. Again, we could mathematically do it and figure it out, or understand. Basically, let's say I remove the poorest kid, the kid with the fewest chocolates. Now the remaining kids at least don't have to compensate for that poorest kid also. So overall, they need to do a little bit less compensation than earlier. So the average will go up. The average for numbers from 1 till 9 is 5. If I remove 1, then the average will go up more than 5. Exactly how much, I don't even care. So then the mean of S is less than the mean of T. That can also be true. So this one also gets rejected. Third one now. Tell me, can we make the average of the bigger set greater than the average of T? If so, what kind of number should we remove from S? Yeah, one of the larger ones, something like 9 or 8. If I remove those numbers or one of those numbers, then overall I've removed one of the richer kids or the higher values, then the overall average will come down slightly. So, which of the statements cannot be true? They can all be true in at least one situation. That's why the answer is D here. I don't think anyone mentioned D initially.
Hi Anish. Actually, I solved on the same lines as you, where if you deduct the mean, then you can get that the mean of S will be equal to mean of T, and if a smaller number goes away, one
Come to
group
your
will have
question.
higher. And so my question was that I was actually looking for an option which says all of these, because all of these can be true, right?
Why do you care about can be true?
I was not able to just get that none of these cannot be true equates to all of these being true.
Okay, all right. So now this is a comprehension issue. All of these can be true, you are saying. Right.
Yeah, because I could get examples of all three.
Yes, all of these can be true. So now if I ask which ones can not be true, would you still say all of these? Or would you say none of these? Let's say this much is done, right? This much we have proven that they can all be. So, okay, let's take another example. We can all speak English. Okay, doesn't mean we always speak English, but we can speak English. Fair so far?
Yeah.
And let's say it's true for all of us. Then I ask you, which ones of us cannot speak English? What will you say?
Which ones cannot? Nobody.
Nobody, none of us. Because we can all speak English.
Yeah.
Same thing here. Take care.
Yeah. Thanks.
Anyway, process it more if you need to discuss it again. Tell me, this one felt a bit heavy, huh? Let's try this. Chalo. Let's try a slightly different kind of question. The average length per film for a group of 21 films is T minutes. So first of all, when I notice variables, I get slightly uncomfortable, right? I'm not as comfortable dealing with variables T minutes than I would have been with, let's say, 60 minutes or something like that. So because I'm slightly uncomfortable, I'll spend longer here and make sure I understand what's going on. So what are they saying right now? Okay, the average for these 21 films, in my mind, I'm thinking, okay, something like maybe 90 minutes or something like 120 minutes. So on average, each film was this long. That's what they're talking about so long, so far. Fine. Now, if a film that runs for 66 minutes, okay, so there's a film that's 66 minutes, is removed from the group. So there are 21 films, they've removed one film and they told us the length of that film. And replaced by one that runs for 52 minutes. So one thing I noticed right away, it's getting replaced by a shorter film. Right? A longer film is getting removed and a shorter film is replacing it. Okay. What is the average length per film for the new group of films in terms of T? So again, the options are also all very weird. T plus weird fractions, 21T plus something, right? Weird thing going on there. And that can add to our level of discomfort. Like I said earlier also, all the more reason to spend longer to process things, to digest things, to make yourself more comfortable with the question. So overall, what's going on? There are 21 films. They've given us the average of the films in terms of T. They've given a variable for the average, or an alphabet for the average. And then one film is getting removed. It's getting replaced with another one. And now they've asked us for the new average. Why won't the average just be the same? Well, because the sum is changing, right? 66 is getting removed, 52 is getting added. So the sum will change. The total number of films is still 21. And that's why the average will change. So that much makes sense. Now, of course, one way is that I just get into the maths of it all. Let me quickly go through that. So initially there are 21 films. So I'm thinking about the total minutes. The total minutes are 21 times T minutes. Why am I thinking in terms of total? Because from this total, then I will subtract 66. To this total, then I will add 52. Right? So minus 66 plus 52 essentially is nothing but minus 14. So then the total becomes 21T minus 14. Remember, this is the total. So the average would be this whole thing divided by 21 films. So divided by 21. So 21T upon 21 minus 14 upon 21, which boils down to T minus 2 by 3. So the answer, as I think everyone who shared an answer, is B. So this is one way to deal with the question. Now, nothing wrong with it. But yeah, even figuring this much out could be troublesome for some people, just dealing with variables in the question also, in the options also. So while there are many other approaches, one more approach that I talk about often also is that whenever there are variables in answer choices, I can assume some easy values. But I want to remain more focused on averages for this session. So let's think of the whole question in another way now. Remember, I said earlier when I read the question, 66 minutes versus 52. Overall, the time is reducing. I'm replacing a longer film with a shorter film. Therefore, what will happen to the average? Can I say right now, just by looking at these two figures, will the average go up or will the average go down? It'll go down. Indeed, it'll go down. So, at this stage, are there any answer choices that I can already reject based on the understanding that the average will go down? The average will be less than T. Can I reject any answers? A, gone. T plus something. C, that's a huge answer, 21T plus something. Also D. So you missed C. C also and D also. These are all greater than T, so they can be rejected. Remember, I said at the start of the session also, answer choices are a resource that we should use. So if nothing else, at least I'm down to a 50-50 shot in a matter of seconds actually, after reading the question. Right? As soon as it becomes clear to me that, oh, a longer film is getting replaced by a shorter film. Forget the numbers, forget the exact values. Shorter replacing longer. Therefore, average will go down. Therefore, anyway, the average has to be less than T. 3 options gone, attack. Okay, 2 options left now. So again, maybe at this stage, again, I get into the whole maths like we did earlier and figure out the answer. then one thing you might be wondering, then what was even the point? Well, one point anyway is, who knows, maybe I could actually reject just one extra option also and get to the answer straight away. Would have been well worth it then. Even if I couldn't get all the way to the answer, I'm at least already at a 50-50 shot. In case I'm running short of time or anything, I can use this. Or even if I have the time, I still need to go through the whole thing. If I make a calculation mistake, I'll be able to catch it. If I get an answer which is t plus something, I would know it's wrong. Also, I am already, my level of confidence is also gone. So in my mind, I'm feeling better about the question once I'm down to two options. Oh, now I'm so close. Now I can probably get it, which I find is very helpful also. Chalo. But now let's think of how else could we answer the question, apart from that traditional approach at this stage. For that, let's try to understand one more thing. Again, coming back to chocolates, and I'll come back to the question. So let's say there are 15 kids, and on average, they have 20 chocolates each. Question for you. How many chocolates should be removed to make the overall average 19? Or in fact, let's put a step before that. How many chocolates does each kid need to give away to make the average 19? Tell me for this question first. Currently, 15 kids have an average of 20 each. That's the average. How many chocolates does each kid need to throw in the trash can or something to make the average 19? Just the one? One chocolate each. Anyone not clear about this? Or another way to think about the whole thing, overall, how many should we remove? Well, 15 kids, 15 times 1, or 15 chocolates. So if I remove 15 chocolates or 1 chocolate per kid, the average comes down 1. If I give each kid 1 extra chocolate, in other words, I overall distribute 15 more chocolates, the average will go up by 1. Right? That's what's happening. Now, these are chocolates, but let's say we can break chocolates also. Let's say. So if I give 7 chocolates, 7 additional chocolates. First of all, if I give more chocolates, the new average will be more than 20. That much is there. But if I give 7 additional chocolates, will the new average reach 21 even? No. Right? Because I'll have to break chocolates and distribute among the kids. So they'll get half a chocolate or something like that. The average will not reach 21. So I'll now use this understanding in our films quest. Overall, if each kid returns 1, then the average comes down by 1. If each kid gets 1 extra, then the average goes up by 1. I can think in terms of each kid, or I can think in terms of overall also. If overall I give them 15 more chocolates, the average goes up by 1. Overall, if I remove 15 chocolates, the average comes down by 1. Now, back to our question. What has happened here overall? Overall, we have removed 14 minutes from the time. And so basically, we've removed 14 chocolates. And there are 21 films or 21 kids. So what will happen to the average? Will the average reduce by something less than 1? Or will it reduce by something more than 1? It will reduce by something less than 1. To make the average reduce by exactly 1, I would have had to reduce 21 minutes. Then the average would have been t minus 1 in this case. If I subtract 14 minutes, then the average will be greater than t minus 1. Just this understanding, in fact, already is enough to get to the answer. Sure, I could get more mathematical here also. T minus essentially 14 by 21. Just the average of that difference separately, and I subtract that from t. For our purpose, though, for this particular question, just the understanding first that the answer will be less than t helped us get to a 50-50 shot. And then understanding that, oh, anyway, because overall the reduction is by 14 minutes, brackets less than 21 minutes, overall the average will not come down by 1. It will come down by something less than 1. So t minus 3 by 2 gets rejected. That's 3 by 2 is 1.5, more than 1. T minus 2 by 3 is the answer. Bata, is this clear? Tell me in the chat.
Anish, I had a question. I didn't essentially get that. Why did you say, like, if I have to get the averages of less than 1, reduce it by 1, then I have to minus 21 minutes.
Okay. Was this clear that if
Yeah.
15 kids, 20 chocolates, and I want to now make the average 19, what will we do?
Yeah, I'll take away 1 from each kid.
Overall, we
reduce
take
it
away
by-
15.
Yeah.
If we take away 8 chocolates, not 15, then what will happen to the average?
It will not be 19, it will be more than 19.
19 point something.
Yeah.
If I take away 30, then what will happen?
It'll be less than 19.
How much will it be? Can you tell me exactly?
18.
18.
Yeah.
This much is clear?
Yeah.
Okay. So now, in the films example, first thing to understand is that essentially films are, you can think of as kids, that each film or each kid has this much length or these many chocolates. So the duration becomes chocolates. Does that make sense?
Yeah.
So now let's not even use the terms kids and chocolates anymore, but each film has certain minutes. Overall average is T. Basically, if a film was able to give minutes to each other, overall they would be even at T currently. Now what has happened? Think about it. One is going out, coming in, or think another way. Overall, we are removing 14 minutes. Till here, are you with me?
Yeah.
Removing 14 minutes for 21 films.
Yeah.
So if I removed 8 chocolates for 15 kids, the average would not have come down by 1. It would have come down by something smaller.
Yeah.
Similarly, if I remove 14 minutes for 21 films, the average will not come down by 1. It will come down by something smaller.
Got it.
If I remove 21 minutes, then the average comes down by exactly 1.
Got it.
Okay. Tell me any other questions? All right. So now there are 2 ways to look at it. See, one is, oh, I couldn't do this question this way initially. And that is absolutely fine. Right? You're going through a journey of learning. That's the objective. So no matter how you do a question initially, and even if your answer is correct, the goal still is to try to learn as much as you can through that question. So one mistake I find people often make is that they only analyze those questions which they got wrong. Anyway, if their answer is correct, they just skip it entirely. One way to think about it is that time is wasted then. Let's say you did 10 questions, all 10 were correct. What new have you learned? What new thing have you learned then? If you're not analyzing them, right? Then essentially that becomes a waste of time. So similarly here also, even if let's say initially you weren't able to process all this and you went about this question any which way, fine. But once you are done, then maybe you can start thinking about these lines, about these things. For example, oh yeah, of course, the average has to be less than T only. Of course, it had to be T minus something. Oh, I didn't notice it earlier, but I could have rejected 3 answers just based on that much. Even if you're processing all this later, fine. Maybe you can use it in the next question. Along the same lines, oh, t minus 2 by 3 and t minus 3 by 2. So one option is t minus something less than 1 and one is t minus something more than 1. For 21 films, the difference is anyway coming down by something less than 21. So the average won't go down that much. It will be something more than t minus 1. It will be t minus 2 by 3, right? So afterwards, you could process all this. The point is not that you should be good at solving questions from the get-go. Obviously not. Obviously not. If that were true for all questions, then anyway, you should be done with the GMAT by now. Right? Obviously, there are things to learn, things to improve in. So important thing becomes that you give yourself that opportunity every time to learn. Either at the start of the question, during the question, or after you're done answering the question. Tell me then, what have been your takeaways from this session?
Can I go first, Anish? I think the takeaway for me at least has been to not just look at a question and start solving. Is the bigger, it's like you rightly mentioned earlier, it's not just about getting the right answer, it's about kind of interpreting in a different logical ways where we don't have to sit and solve, but maybe try to do it in different ways.
Yeah, indeed. Yes, that's something that I talk quite a bit about with my students also. Try to figure out multiple different approaches for each question. And don't be satisfied with just one approach, because often that will be the traditional approach that you're already the most comfortable with. Indeed.
Anish, one point on this, if I may.
Yeah.
Theoretically, we know this, but what happens and what I have experienced is when you are on, especially on D-Day, even if you give mocks, you're so scared and that you start solving right away. You know it, but you cannot implement it. You can implement it when situation is comfortable. You are solving 10 questions or 20 questions and you're consciously keeping that in mind. But in high stake environments, I think you just drop it away when you're scared and insecure, and you just give in and you just start solving, and yeah, it really messes things up.
Yeah, I get that and I completely agree with that. So tum batao then, what do you think could be a solution for this?
No, I'm looking up to you on this one.
I know, but let's think of it together. What could be a solution? So why do you think the brain goes to those traditional approaches under pressure, high stakes environment?
Because you are not in control of your own reasoning, and because you think there are gaps and you don't trust yourself.
Yes, very valid. Anna, you feel more confident about traditional approaches than you do with these reasoning-based approaches. Fair?
Yes.
So then I think the question becomes, how do I develop confidence with reasoning-based approaches? Is that a fair question?
That is.
Think about it. How can we potentially develop confidence?
During the learning journey, I would say to step out like we did in this session.
Step out as
step out from your own conventional framework of thinking.
Yeah.
And really try to think logically about it and contemplate and revisit. These are the things we can do. I mean, rationally making an error log.
You answered it more comprehensively than perhaps even I could. Realize all we did was we just tried to understand, right? Ki kya chal raha hai? Why do we even do that? What you said is absolutely correct. And that's very right? Under that stress situation, you go to things that you are most comfortable with, things that you feel have the best chance of getting you to the answer, right? And with reasoning, one issue is that, oh, I might go down that path, and then after a while realize, oh, I still don't have the answer. Then I will have to start from scratch again, right? So under time pressure, then all those things come to mind, and then often we think, oh, no, I want to stick with something that is safe or something that I'm more confident with. right? Maybe with time, as you do more of this kind of practice in which you are engaging yourself, you are trying to understand, how could I look at this question? Not mathematically, but just how can I visualize it? Maybe with time you get more comfortable and more confident with these things also. And then maybe that choice, maybe not for every question, but at least sometimes you start even preferring logic-based in some questions at least.
Agree.
So yeah, I would break down the whole situation, right? I wouldn't directly think about, oh, what do I do for the exams? I'd focus on what do I do in my practice at least, in my preparation journey at least. That can eventually lead to a better outcome. So do you usually, when you practice, do you think of reasoning-based approaches in your practice?
When I started out, I did not, but now I'm increasingly trying to.
Okay. So then I think that's already a step in the right direction. See, I don't think there's a fear that you will forget the traditional approaches that much, right? I don't think there's a fear that you'll forget how to calculate average using a formula. Is that fair?
Yes.
So you might as well try to learn something new also. ठीक है? और बताओ, takeaways.
I think for me, one thing is if you don't get into the formula right away and just spend, let's say, 10-20 seconds more with the question, you can maybe eliminate a few options right away. And then you can go into your formula if you want. But if you just take a step back and don't just put the formula right to paper, then some things might just come out very glaringly from the question right away.
Indeed. Yeah. So my points are also along the same lines. See, and it's not like I consciously decide that I'm going to rush. Yet in the moment, and what ends up happening is that it almost feels as though I'm not in control. Not even a second passes after I've read a question, I'm into solving the question, right? I'm into adding things, multiplying things, getting to the answer, right? It almost feels as though it's autopilot, right? Just going through the motions. So then, yes, a part of that becomes that I want to try to get out of that autopilot mode and I want to get into an active mode of practicing, right? I don't want to be in that autopilot mode anymore, but I'm just going about things. So what tactics can you use now to try to get out of that autopilot? One is obviously that the more you see value in these approaches, the more you'll be inclined to try them yourself also, right? The more you see value in how, oh yeah, we could get to the answer so easily. And that's, in fact, one reason why I let you do questions first and then discuss approaches, so that you can yourself notice, oh yeah, I didn't really need to do 360 into 6, those weird calculations, right? Then you can maybe appreciate these things more. And then it can be even tactical, like, oh, I'm not even going to hold a pen while I'm reading a question, while I'm understanding it, right? That way, maybe you force yourself to pause and think. Anyway, don't even think about preparation in terms of number of questions. Because when you think that if you've practiced a lot of questions, that's been a good day. When you think you've practiced few questions, it's been a bad day. Then you will automatically get into a mode of rushing through questions because you want to do more and more so that you think you have done plenty in a day. So it's not about the number of questions you practice. It's about how much you learn from each question. Right? For example, in this almost 2.5 hour session, I don't think we even reached 2 digits in terms of how many questions we did. Versus many students I find they do, for example, 10 questions in 20 minutes, 25 minutes, something like that. Right? Just in a mode of, oh, let me just get through the questions. So anyway, tell yourself, okay, today I'm going to do 3 questions in this 1 hour, for example. That's the kind of time frame I'm looking at. Why? Not because I want to start slow. No, because I want to learn as much as I can from each question. And as you start doing more of this, as you start seeing the benefits yourself, you start getting more and more convinced also. So yes, some things that you can try to kind of force yourself, like not holding a pen, and then some things that will, with time, help you yourself develop more confidence with these approaches, so that overall we take more time to digest, we are not in a rush to solve the question. Overall, the second statement here, patience itself is also a skill that we need to develop. It won't just come overnight, right? So if you think of it as a skill, then you start working on it that way. Okay, I will develop it with time, slowly, slowly. Patience is not the same as doing things slowly. By being patient, I find I can answer most questions much faster than many of my students. By being patient. So that's the mismatch that you need to be clear about. Being patient does not mean that you are going to take longer. Often being patient means you'll be able to notice things that otherwise you wouldn't have noticed. And by noticing those things, you will be able to answer the question even more quickly.